Alright, so Unit 6, Lesson 5. We're skipping 4. Since 4 is pretty long, I'll save that for Monday, since today's short. Yeah, 181. Yeah, we are going to do the unit circle. I promised Mr. Moore we'd do the unit circle. It's, like, really important. You need it for Math 30. Alright, so class example number 1. In each case, determine the value of x to the nearest whole number. So this is just using your regular trigonometry. Okay, these are right triangles. This is not what we're doing today. It's just to get used to the sign, okay? So in this case, I have a missing angle I'm trying to find. I have an opposite. I have a hypotenuse. So you should know it's sine x equals 8 over 14. Okay, opposite or hypotenuse, that is your sine. Okay, then to get rid of sine here, we do our sine inverse. So in your calculator, you're going to put in sine inverse of 8 over 14, and that's going to kick out your degrees. In this case, it kicks out 35, which is x is 35 degrees. Okay, all right, and then in part B, again, we have adjacent this time, and we have hypotenuse. So we want to use cosine this time. So but I have the degree. So this time I have cosine of 40 equals 19 over x. Got to do a little algebra here. Essentially what's going to happen is that these two are going to switch because you're going to times the x over, and then you're going to divide the cosine over. So x equals 19 over cosine 40. So x equals 25 in this case. Okay, and that's a review of your general trigonometry. You probably remember that. Okay. All right, so now we're going to use SOHCAHTOA to help us determine the length of BC. Now, these are good problems, again, for your diplomas and stuff like that later. Not for this year, obviously, but for next year, because it has a lot of things in it. Okay, and you can look at it. A lot of people that are a little bit weaker are going to look at it and see BC, and they're going to think, well, I don't have enough information. But that's what you have to go ahead and get to in terms of finishing. Okay, so the first thing you want to do is you got to know that this is 90 as well. Okay, and I can find BD. I can't start on the right triangle because I have no length on the right side. Okay, think of me as two triangles here, number 2, number 1. So triangle 2, I have no lengths. If you don't have lengths, you really can't do much. Okay, but on triangle 1, I do, so I can figure out what the missing lengths are so that I can get this piece, which will help me for triangle 2, and this piece is part of BC. So we're going to have to do, first off, let's find BD. So to find BD, I have sine 20 equals BD over 12.5. Opposite over hypotenuse, hypotenuse 12.5. So then BD is going to equal 12.5 times sine 20. It's a sine right there. Just put in your calculator just like that, and it'll give you that BD is 4.275. We're going to kind of save that one because that is part of our answer, because that's one chunk. We need to get DC, but that'll come later. Okay, now we're going to find the other side, this side, so that'll help us get into triangle 2 since they share that side. So I'm going to go, I'm going to use the same degree. So let's go 20, it's adjacent over hypotenuse. So let's go cosine 20 equals x over 12.5. You can do Pythagorean as well. Yeah, I think this is a little faster. Okay, just times 12.5 over, or let's not call it x, let's call it h, the height. 12.5 cosine 20 equals h. H equals 11.746. I'm doing it 3 decimal places because it told me to up here. Okay, so 11.746 is the height of the triangle. All right, so now we do have a side over here, so now we can go ahead and try to get this side. So let's take 35. We have the side opposite, and then we want to find the adjacent. So opposite and adjacent, what's that go with? Tan. So I want to do tangent. So I'm going to go tan 35 equals opposite, which we just figured out is 11.746 all over x. Okay, so like the last problem, we're just going to do a little switching around. The x will come up here, the tan 35, they're pretty much going to switch places. Like that. And excuse me, I keep doing that. Let's call it DC. Okay, and then you put that in your calculator. DC will get you 16.775. Okay, and so we want to take this piece and add it to this piece to get the full length. So we can do that right now. And once we do that, we get 21.05 centimeters total. That is B to C. Okay. All right, so now we're kind of stepping more into the actual sine law itself. Okay, sine law, what it does is, okay, so just kind of talk about it here before we prove it. We'll prove it in a second. Okay, so just be familiar. What this means here is the length, the opposite, the angle is like big, like this is angle A. So this angle creates this side. So that's side A. Angle B, this creates side B. We should do lowercase b. Angle C makes it side C. Okay, why that's important is because sine law's whole thing is proportions. Okay, and what I mean by that is that it makes sense that this side's the smallest, right? Well, this is the smallest angle. That's not a coincidence. Okay, angles create sides. So your smallest angle will create your smallest side. Your biggest angle, like B, is your biggest angle. It creates your biggest side. Okay, so my point is that when you're doing sine law, and that's what this is, we're going to have proportions of their sides because side over this angle, the sine of the angle, side over sine of the angle, they're all equal. So if I take the small side, whatever it was, and it's over sine of the angle, these proportions will be the same as the B and C. Okay, so again, Law of Sines is essentially proportions. It's saying that they're going to have the same proportions. They have to. Because once you have a side associated with an angle, that triangle has to have the same dimensions as long as that you have the proportions set up correctly. Okay, so let's get to that proof here of why. Okay, so what they did is they just drew two triangles here, and they put ABC and then ABC, but they just flipped it. Okay, so let's complete the following work to show that A over sine A equals B over sine B. So what we're going to do is sine A equals opposite over adjacent, or excuse me, opposite over hypotenuse. So right here, that's CD over AC. Okay, so opposite over hypotenuse. Here's the angle. So that's this. Well, AC is also little b, because here is B over here, so it's little b. So what we can conclude is that CD, if I multiply that B over, CD is B sine A. Okay, just pretend that's not here in the middle. Just times the B over, you have CD equals B sine A. Now it's looking at the flip version. sine of B is also CD over BC. In this case, BC equals little a. So CD is the same as A sine B. Okay, well, if CD equals this and CD equals this, they equal each other. So B sine A equals A sine B. All right. Now the last thing you can do is, and I'll do a different color here so we can kind of see it, I'm going to divide the B over, divide the A over. So the B is going to go over here, the A is going to go over here, and that's going to give you the sine law. Sine A over A equals sine B over B. It'd be the same thing for C. That's why C is part of the sine law. Okay, now we're going to do a few examples, and then we'll be done. Okay. It's kind of important here to highlight this, I think, is that to use the sine law, and in this unit, the hardest thing that my classes struggled with last semester was remembering when to use cosine law and sine law. Okay, we don't know cosine law, so we can't really talk about it, but that's something to keep in mind. But in order to use sine law, you have to know 3 pieces of information. Okay, you have to know 3 pieces of information because for your proportion, you have to have 3 of them in order to get the fourth. If you only have 2 of them, you don't have enough. Does that make sense? Okay, so let's get to this problem here. So in this problem, you can see I have 3 pieces of information. I really have 4, though. Why do I have 4? Yeah, we know the third angle. You'll always know the third angle. If you have 2 angles, you always know the third. So just for practice, we don't really need it on this one, but just for practice, let's do it. 35 plus 75 is 110, so this one is 70. Because I know that 70 plus 110 is 180. Every triangle is 180 no matter right or no, not right, right? Oops, too many rights. Okay, all right, so we're going to set this up here. It says triangle ABC from class example number 2 is shown. Use the sine law to calculate the answer. So we already did this problem, but we're going to use sine law to get the answer. So I have C and side C. Okay, it wants me to find BC. I want to take 75 and little a, excuse me. So what we're going to be using is this part, and let me write the whole thing real quick. Okay, you don't need all 3. Okay, so people get confused on the sine law. It's like, oh, well, what about my C? You don't need C. You only need groups of 2. You can pair any of these together in groups of 2. Okay, because remember, we want 4 things, so we're trying to figure out. You also can have it flipped, so you can have the sides on top. And I always do that. In my opinion, it makes the algebra easier. What are we trying to find here, a side or an angle? A side. That's the stuff you want on top. So what I mean by that is, this is angle A and side A. So I'm going to go A over sine 75. Okay, and then I'm going to go 12.5 over sine 35. Now you can kind of see I have 3 pieces of information. A is what I don't have. Okay, and you have one quick algebra step now. What we're going to do for algebra is we're just going to multiply both sides by sine 75. And that'll give us our answer. It gives us 21.05, which we already knew that's what it was. We just got it faster. Okay, if you have calculator problems, let me know. Make sure you're in degree mode. Make sure you use your parentheses very thoroughly. Okay. All right. Example 4. Okay, use sine law of the triangle shown to determine the measure of angle ACB to the nearest degree. So we're trying to find ACB. So we're trying to figure out this guy. Okay, so what is my problem with this, or what do you notice that's going to kind of maybe annoy us? One angle, yeah, that makes things a little difficult. Do we have 3 pieces of information? Yeah, we do, but in terms of angle C, do I have side C? I have nothing with C. So even though I need this angle, I can't solve for it because I don't have anything for that proportion. What's that? Okay, Pythagorean theorem we can only do for right triangles, though. So we can't use that one either. Yeah, good question, though. Remember, Pythagorean theorem is only for right triangles. But let me ask you this. This is side B, I have side A. Can I figure out what angle B is? And then once I get angle B, I now have 2 of 3, so I can figure out angle C. Okay, so remember, whenever you're going for angles, if you want to get 2 of them. Once you get 2, it's over. Okay, once you get 2, it's over. So here's what we're going to set up. We're going to find angle B first. That will give us what angle C is. So we have, we're finding an angle, so I'm going to put the angles on the bottom. No, excuse me, on top. Sine 110 over 9.4 equals sine B over 6. We're just going to times the 6 over. Okay, and then you're going to get that sine B, hopefully you get, is 0.5998. Last class they asked how many places should you go. The more the better. 3 is probably pretty good. 4 is perfect, whichever. Okay, and here, to get B by itself, we got an inverse. So I want inverse sine of 0.5998. Okay, and that gives me for B 37. So angle B is 37 degrees. So now we just take that and we go 110 plus 37 is 147. So I go 180 minus 147. Okay, which gives me 33. And if we wanted, we could find side C now. Any questions there? Okay. All right, we got 2 more. Well, actually, 1 more, and then it's part B's on the next page. All right, surveyor measures the baseline of PQ 440 meters long. So we know PQ is 440. Says he takes measurements of an A landmark R and P and Q and finds a QPR. So QPR is 46 and PQR is 75. Okay, let's make sure I got those right. QPR, yeah. Okay, and PQR. So we don't know this side, but they want us to figure out the perimeter. Okay, well, we do know R, because we know that we can add those up. So let's do that really quickly. That's going to be 110, 121, so we should get 59 up here. 180 minus 120. Okay, so now we can do that, because we have one side in relation to the 59. We can find PR and PQ. So we're trying to find sides, so let's have sides on the bottom. Or excuse me, top, sorry. 440 over sine 59 equals, we'll call PR over, PR goes with sine 75. Okay, that's the first one we need to do. Might as well set up the second one. 440, we use the same proportion, equals RQ over sine 46. Okay, and then solving, we're going to go sine 75 times 440 over sine 59 equals PR. Kind of doing both at the same time here. Sine 59 or sine 46 times 440 over sine 59 equals RQ. So PR, you put that in your calculator, PR comes out to be 495.83. And that makes sense because angle Q is the biggest angle and it makes the biggest side. 495 is bigger than the 440. Okay, and we're assuming it's going to be bigger than the next one, and we'll find out. RQ comes out as 369.25. Okay, so it wants the perimeter, though. The question says they want the perimeter, so we need to add all four of our lengths now. We need to add this one, and this one. All four sides. When you do that, the perimeter, so perimeter of triangle PQR, we get 1305 meters. Okay, and then part B, the last part here, we need to kind of remember that information, so hopefully you have it. So, let me put a triangle in here real quick. So now I want to find the area of the one we just did. Okay, so we have our P, Q, and our R. We got this is 495.83. Okay, we have a, let's see, we'll leave that for a second. We have the 440. Okay, so let's take it in where we have this is 46. Okay, calculate the area of PQR. Well, what's the area of a triangle? Half the base times the height. Well, which piece of information do we not have of that? We don't have the height. I have the base, I don't have the height. Height, we're just going to draw an altitude straight down, makes it 90. Okay, what's that? Can't divide the bottom by half. Okay, that's kind of important because we don't know. The only time that does that for half if it's an isosceles and equilateral, and it's neither because every side was different. What's the name of a triangle that every side's different? They're not the same. Scalene, good. Okay, so you can't assume, because you can do an altitude, Nick, a good question though. You can do an altitude, like see this triangle right here? If I did an altitude right here, it doesn't cut it in half, right? So every altitude doesn't cut in half. Okay. Alright, so, but back to what I was saying, what are we doing? We're doing sine, right? All that stuff. We have a right triangle now. So we do that stuff from the very beginning of the lesson. Right, I have opposite I want. That's my x or my h. We'll call it h for height. Okay, and I have my hypotenuse. So I have sine of 46 equals h over 495.83. We're going to times the 495.83 over, and that's going to kick out our height. For your height, you should get 356.67. Now we have all of our information to do our area of triangle formula. So 1/2 356.67 times 440. That'll be the area of the triangle. Okay, and that comes out to be 78500 meters squared. 7 78,500 meters squared. Okay, any questions or concerns with that? Okay.